Gangrene is problematic because what happens is once the bacteria actually colonizes your dead and dying tissue, what it will do is try to make sure it has a food source, and what it will do is kill the tissue ahead of it, right? So if you get gangrenous tissue, now gangrene is bacterial, and we can treat it with antibiotics, but generally all it will do is slow it down. So you never want your tissue to go gangrenous because, for instance, it has killed more soldiers probably than almost any other pathogen, historically speaking. So if you have shrapnel, right, in a wound, you got to get the shrapnel off, but then you also have to get the dead tissue off, which is not comfortable. Otherwise, you can get gangrene, and if you get gangrene in the limb and you can't get ahead of it, what do you have to do? You have to amputate, because if you don't, it can kill you. It's kill you dead. What? Oh, what they do is immediately after the injury, before the bacteria set in, you got to clean the wound, of course, right? You got to get everything out, because a lot of times the actual shrapnel has pathogens, bacteria on it. So you got to clean the wound, and then you have to take off the dead tissue, right? You don't leave dead tissue around, so you cut it off. Yes, they take it off. So there are two different kinds of gangrene. There's dry gangrene and gas gangrene. Dry gangrene is like what you would get. It doesn't tend to have a bunch of pus associated with it. Like if you got frostbite, right? You got frostbite and then the bacteria starts to sort of dryly eat your tissue ahead of it. That's dry gangrene. The really gross gangrene is called gas gangrene or wet gangrene, and it's really stinky and nasty and like will kill you dead and disgust you in the process. Then let's talk about what happens with tissues as they age. Okay, so what do we all have to look forward to unless we get hit by a bus tomorrow? We all have tissues changing as we age. First thing that happens is your epithelial tissues tend to thin. So I want you to think about your epidermis for a second. And the superficial surface of your epidermis is, of course, made of what kind of tissue? Keratinized stratified squamous epithelium. So if you've got a 20-year-old versus an 80-year-old, I want to talk about the difference in the thickness of their epithelium. What happens is exfoliation, the rate at which you lose cells, isn't age dependent. It's basically just an abrasive process, right? But cell division is age dependent. So what will happen is you will lose cells at the same rate, but you don't regenerate them at the same rate, right? And so what happens is slowly, your epithelium starts to thin. And if you've ever dealt with an incredibly elderly person, like 80s, 90s, or 100s, their skin is so thin that if you move them improperly, their skin will actually tear. Yeah, it's like paper thin, really, really thin. So your epithelial tissues tend to thin. And then what also happens is you start to break down collagen fibers and elastic fibers, and you don't replace them as readily because your protein synthesis slows, right? So what happens to the elasticity and the snapback and the strength of your tissues? Well, they tend to lose their elasticity, lose their strength. You also lose collagen in your bone, which tends to compress your bones, right? So you can lose height as you age as well. So, and then your muscle and your nervous tissue will also begin to atrophy, but a bunch of that is use it or lose it. We tend to get less active as we age, which is kind of interesting. So in my generation, before we had electronics everywhere, right? Generally speaking, teenagers were out of the damn house, like doing something with other teenagers that was, right? And now mine will literally sit in front of the Xbox for like 7 hours. He says he's playing with his friends, but he's playing with them long distance, like they're not in the same room. But typically speaking, you were really active at a certain point in your life, and then you get busy and you start going to college, and you're like, I don't really have time, I got to sit down and do this crap. And then you finally get the job that you wanted. And most of the jobs that we're looking for are jobs where we can sit the hell down, damn it. Like, I waited tables so I don't have to do this anymore. And then basically you're using your muscle less and less as you age. And you start to lose muscle mass. And you start to lose nervous tissue as you age. But it's use it or lose it. If you will stay a little more active and stay a little more healthy, you don't lose it very much. Because if you think about it, you probably all know somebody who's 20 years older than you and in better shape than you. Yeah, but that didn't happen on accident, did it? Anybody in their 40s accidentally hot? Hell no, they're not. They don't eat what they want, and they wiggle far more often than they actually want to. They're like, oh, damn it, stupid climber. I have a climber in my house. I love it. After I'm done with it, I love it. And I complain every single time. My son's like, why do you do that thing? I was like, I don't want to be ugly yet. That's all. It's the only reason. I'm not ready for ugly. Trying to put it off a little bit. Okay, so a lot of these changes are due to diet and circulation. Okay, so the last thing is how to build an organ and then learning the simplest organs. So I want to talk about what tissues have to do with organs. And the idea here is that if I look at a cross-section of maybe a hollow organ, I kind of know what to expect, right? Is that picture not on yours? Oh, okay. Well, I'll give it to you. It's cool. I like it. So I thought maybe I didn't upload the current version for you. I'll put it in there. Okay, so let's talk about this. Oh, we got gangrene pictures up. Did you look at that? Ew, dry, wet. It looks like it's about to burst, like a dead cow. Any other redneck seen like a dead cow that like gets really, 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 really big? Do not kick it with cowboy boots on. That's all I have to say. It's a bad plan. Don't do it. Okay, so if you look at any hollow organ that's not the heart, so let's just do like small intestine, right? Because this one's like, or it's the stomach, right? The stomach has a little extra stuff. So the deal is that you have enough knowledge now to know what general categories of tissue to expect in each place, right? So what would you expect to find in contact with the lumen? What general category of tissue? Epithelial. But then what you could do is, okay, well, if this is an epithelial tissue, I can probably figure out which one it might be, like her logic process, right? If it's in the esophagus, it's probably going to be a stratified, but if it's an absorptive surface, it might have microvilli on it and be a simple tissue, right? So the idea here is not rote memorization. It's like, oh, here's my prediction. Let's see if I can confirm my prediction, right? So it's going to be an epithelial tissue, and then the type of epithelium will tell you structure-function relationships, right? You're like, oh, I see cilia, then I know it's going to wiggle something around. I see a stratified tissue, then I know it's actually going to be dealing with abrasion, right? Okay, so what's deep to that? Even if you don't know the specifics, after you run into the epithelial tissue and then the basement membrane, which isn't a tissue, what tissue is going to be deep to the epithelium? Connective. And the type of connective tells you something about structure-function relationships. If the connective tissue needs to be strong in a bunch of different directions, it might be what? Dense irregular. If it just needs to be a little bit strong and a little bit elastic and kind of like a space filler, it will probably be a reeler. Yeah, a reeler is the most common one that you're going to run into. Does that make sense? So the tissue that is there can tell you something about structure function, or you can do it the other way. The function can allow you to predict what tissue you think you'd find there, right? Okay. And then you go deep to that connective tissue, and generally you're going to run into one or multiple layers of muscle. And if it's any organ except the heart, what kind of muscle is going to be in the wall of the hollow organ? It's going to be smooth muscle, yes? It's going to be smooth muscle. So you know what to expect there. That layer of smooth muscle, usually to get things to move through hollow organs, especially if you're moving solids, you usually have 2 layers of smooth muscle. So let's look. Okay, so this is my small intestine. I'm stretching it out, okay? I want to talk about why 2 layers of smooth muscle. The first layer, the one that's closest to the lumen, that one has the smooth muscle cells going circular. Do you see that around? Okay, so if I contract those smooth muscle cells, what's going to happen to the diameter of the lumen? It's going to get smaller, right? Okay, and then the next layer out, more superficial, it has longitudinal smooth muscle fibers, okay? If I contract that one, what's going to happen to the length of the organ? It's going to get shorter. So how do you move stuff through your intestines? You squish it, and then you pull it. You squish it, and then you pull it, yeah? And as long as you start from the proximal end with the squishing and pulling, then you don't end up with poop in your esophagus, right? Because that's a bad day. So the worst day. So basically you squish whatever solids are in there and then you pull that direction. And that combination of squishing and pulling makes things move through tubes, and it's called peristalsis or peristaltic contraction, right? Now, if you are the stomach, and the reason I didn't say this one was the stomach is because the stomach moves big chunky solids and it actually has an extra layer of smooth muscle. Does that make sense? Okay, so what's going to be on the outside? What's going to be on the outside is connective tissue, but if it's just hanging out by itself, it will have epithelium on top of it. So what do I mean? Some organs are like stuck to other organs, and then they're going to have connective tissue on the surface, and some are hanging out with the serous membrane on the top. And then it would be connective tissue, epithelial tissue. Does that make sense? Kind of depends on whether it's like hanging out by itself or it's stuck to something else. Is that okay? So that's what you can predict about hollow organs, and what we're going to see is we'll confirm this multiple times this semester. So the only tissue we didn't see in here is nervous tissue, but generally, by the way, you have nervous tissue hooked up to it to control the contraction of the muscle and to also send sensory inputs, right? Because you can have a stomach ache, right? Your intestines can actually hurt, right? So you have nervous tissue hooked up, even though it's usually not really readily visible in every slide. It is there, conceptually. Okay? Everybody all right with that? Okay, so so the very last thing to talk about is, so let's move on to organs, and let's talk about the very, very simplest organs. So you guys know from before, a whole bunch of cells functioning together with their extracellular matrix is, of course, a tissue. And what's an organ? More than one tissue functioning together. So the simplest organs actually don't look like organs. Because if I have two layers of tissue on top of one another, that counts as an organ, right? So for instance, let's start with one that you already know. This is called the cutaneous membrane, right? It's a membrane, which is just two layers of tissue on top of one another, but it also counts as an organ because they're functioning together. So the cutaneous membrane of the skin has what tissue on the top? Keratinized stratified squamous epithelium, then a basement membrane. And then what's most of the tissue underneath? Mostly dense irregular. Mostly dense irregular. There's also a reeler in there, but it's mostly dense irregular, right? So you've got at least two layers. So that means it counts as an organ, and it's actually the biggest organ in your body, depending on your body size. And even not accounting for fat, because we're not talking about the adipose, it weighs between 6 and 10 pounds. It's a lot of skin, right? So the last 10 pounds you were trying to lose, it's skin. You just leave it alone, it's fine, right? You literally die without it, okay? So, huh?
Have your skin removed.
Oh yeah, you can have your skin removed. Yeah, you can. If somebody lost a ton of weight, huh? Yeah, I could remove it. I don't know how well you turn out and afterward. Can I wait like until you're dead and then I'll remove your skin for you?
That's great.
Okay, that's good. Okay, there are two other kinds of membranes that count as organs. One of them is called a mucous membrane. Mucous membranes are very, very clinically important, and they actually are organs. What is a mucous membrane? It's a moist membrane that's potentially exposed to the external environment, right? So respiratory tract, mucous membrane, okay? Digestive tract, all the way down, mucous membrane, right? Urogenital tract, mucous membrane. So what are those made of? Well, on the superficial surface, it depends on how close it is to the ends, right? Because that's what we were talking about. As it gets really close to the ends, it's more likely to be stratified. But as it gets deeper, it's more likely to be like columnar, right? Some kind of columnar. So the superficial surface is always an epithelium, but the kind varies based on where it is, yeah? And then basement membrane, yeah? And then deep to that, with every mucous membrane is a reeler, connective tissue, right? And so mucous membranes are super, super clinically important because those moist surfaces are usually meant for some kind of exchange, yeah? Which means that they're very hospitable to pathogens. Because you can't say, I want to exchange one thing and then close it to all other things. So where do you get exposed to most of your pathogens? Respiratory, digestive, urogenital tract. Yeah? Because they're moist and they're friendly, right? And they're like trying to get stuff in. It's just that sometimes you get other stuff in, right? That makes sense? Okay. I didn't think about that. I'm like, she got a dirty mind. She's like, yeah, we are trying to get stuff in. I actually didn't even recognize that one. And usually I do. Okay. And then a serous membrane. A serous membrane, by the way, is an organ. I know it doesn't seem like it, but now I'm telling you that your stomach, which is an organ, has an organ on top, which is called the serous membrane. Why does it get to be an organ? Because it's two layers of tissue. What are the two layers of tissue? A reeler connective tissue, yeah? Then a basement membrane, and then superficial to that is a special kind of simple squamous epithelium that has secretory capacity. It's called mesothelium, but I don't have a test on that word. So it's simple squamous epithelium. So it's still an organ, right? That makes sense? So that is a serous membrane. Good? Okay, so those are the simplest organs. Generally, by the way, what we do right after histology is we're supposed to do the skin chapter. But I'm going to do bone because I think you need more help with bone than you do with skin. So we'll pick up skin later on when you don't particularly need my help with stuff that you're doing in lab. So next what we're going to do is we're going to move to bone, and I'm going to talk about how we cover it in lecture and how we cover it in lab and how you should study it and all that kind of stuff. Okay, so today we're just going to barely get started on bone, but I need to tell you some important things. First off, your test is scheduled for next Wednesday, but I've decided to move it to next Friday because the Monday, Tuesday people will just have finished their bones, right? And your bones are on your test, okay? So I'm going to move it to next Friday. Oh my God, why do you guys plan to miss class? Somebody in the last class said, yes. Yeah, you shouldn't plan stuff during the semester. I own Monday, Wednesday, Friday, humans. Okay. And if anybody else wants to, the answer is no. Okay, so the Monday, Tuesday people are behind, and they will just Tuesday have finished appendicular skeleton. So I want to give them a little bit more time to master it. So we are going to do the test Friday. It's going to have the same material on it. It's still going to be anatomical terminology, histology, and bone. Yeah? Okay? Now, that doesn't mean we're off on Wednesday. It means I'm going to start new material on Wednesday, which we won't cover on the first test. Does that make sense? But it will be relevant to the stuff that you're doing. Does that make sense? So, now why am I doing that? Because the bones that you learn in lab, I will also test you on in lecture. And so, do I test on them in the same way that they do in lab? No, I don't. But I need you to put lecture and lab together, and if I get you to study them at the same time, you'll start making connections that you wouldn't otherwise. So all of the bones on your lab white sheets are on this first test. But how are they on this first test? Well, I'm reasonable, and I know that when, for instance, you are looking at the skull, no matter what picture I use, you can still tell this is the frontal bone. Yes? When you are looking at the humerus, you can tell it's the humerus, and with a good enough picture, you could probably even tell left or right. But the freaking deltoid tuberosity, you can't see that unless you got the bone in front of you, right? But you can see this hole, can't you? Everybody can see this hole in every picture. So I will test you on the bones, and I will test you on features that are reasonable to find in a two-dimensional picture. If you can't find the foramen magnum on the skull, you should probably flunk, right? Okay? You can't find the styloid process or the mastoid process, you should probably flunk. So in lab, your quizzing and testing over the skeletal elements will be much harder than it is in lecture. As a matter of fact, you're not going to have a ton of questions off of lab material, but enough to make you make these connections. That's what I want you to do. Okay? Does that make sense? Okay. So we're going to do it next Friday instead of next Wednesday to help those Monday, Tuesday people. And yes, I will figure something out for you. Okay. So let's talk about the functions of the skeleton, and then I'm going to give you guys some tips for studying the bones. Okay. So the skeletal system is 4 chapters. Chapter 6 is the basic organization and development of the skeleton. That's most of what I do in lecture. How do you know how it's organized? How can you predict how did it get that way? Chapters 7 and 8 are axial and appendicular skeleton that you've already been using to study, right? Okay. We don't talk about them a ton in specific in lecture, but of course you've been using them in lab, and I want you to bring them into lecture. Chapter 9 is articulations. Articulations is joints, which is the natural connection between bone and muscle. So how do you know what to study? My notes are always your guide as to what to study. That anatomy book has far more than you could learn over the course of the semester. So you use the notes to figure out what to refer to in the textbook. You don't do it the opposite way. You don't read all of chapter 9 and try to figure out what the hell's going to be on it. You look at what I put from chapter 9 on this lecture material, and then you'll find it in textbook. Does that make sense? Okay. Because those textbooks, by the way, this textbook is sold all over the country for people who are specializing in multiple different things. For instance, if you were doing neuroanatomy, those 6 chapters of nervous system, you would go hardcore into those 6 chapters, right? If you were going to be a dental hygienist, you probably wouldn't even look at those, right? You're like, it's fine, there's nerves in there, probably. So functions of the skeleton, we'll come back to that next time. What I want to give you is something useful, tips for studying bones. How do you study bones successfully? First off, you need to know what the meaning of the features are so that you can tell when it's going to be a condyle, a tuberosity, a tubercle, or a trochlea. So you need to know what condyle means so that you can run into something and say, oh, that's probably a condyle. Condyle is a knuckle-like projection. Now why? Why do you need to know this? Because when you take your lab practical, it's a blank piece of paper. It's not multiple choice. So you need to be able to look at that pokey outy thing and figure out whether it's a styloid or a condyloid or a what the helloid. You have to be able to figure it out, right? So you need to know what the terms mean. You need to know the difference between a fossa and a foramen and a meatus, right? Because it will help you. So that is really important. This is figure 617 in your textbook, or table 617. Figure 617 in your textbook. And if you bought a lab manual, there is also that in your lab manual. Okay? There's also a description of the meanings of all of that stuff. Okay? All right, so you will need that. It will help you dramatically. Okay? And then, by the way, once you find a condyle, if you really want to know what a condyle looks like, don't find one, find 5 of them. So you can say, condyle, 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 got it, condyle, right? Condyle. This one's styloid, that one's styloid, what do they have in common, right? They're pokey, they look like a stylus. So that will help you because eventually you're not going to have a word bank at all. Okay, the other thing that is really useful is this. So let's practice this, and this is a really good, habit. Okay, so you guys have all done the skull now. Oh my God, I love her. Okay, so you all have done the skull now, so you know that this, of course, your cheekbone is actually your zygomatic arch, right? And you know it's actually made of 2 different processes. Okay, so let's talk about how you would be successful. So if your lab instructor puts a pointer or a sticky right here, right, on this side, puts it right here and says, name this feature, then the answer would be zygomatic process. But he could also ask, name this bone. So what you need to do is never divorce the piece from the bone it belongs to. It's called parenting. So this is not the zygomatic process. This is the zygomatic process of the right temporal bone. Right? Does that make sense? Okay. This is the temporal process of the zygomatic bone. Does that make sense? Okay. So that's called parenting. And parenting makes you be really rigid about your knowledge so that you actually know that the freaking temporal bone has so many things on it, right? It's got the freaking zygomatic process and the masseter process and the styloid process and the external acoustic meatus and then the petrous part. But you don't get to say that without saying what bone it belongs to. So listen, do you know sella turcica, but the sella turcica of the what? Oh, do you know? You're like, I don't know, I'm afraid to say it out loud. Okay, last thing, I'm going to keep you 2 minutes extra. Stop wiggling. Trying to help you. Okay, so learning the bones. So here's a bone. You might not have done this one yet. Okay, so when you are trying to learn the bones, and with every paired bones, you have to do left and right. How do you do left and right? It's not random. What you need is a dependable anterior or posterior landmark for every bone. This is a good dependable anterior landmark because if you can't see it, you're looking at the back side of the bone, right? But in order to do left and right, you also need a lateral or medial landmark that you can always find. This is a good medial landmark, right? So in order to position this bone, and this is one of the hard ones, right? In your body, what you have to do is you have to empathize with the bone, right? You're like, I want to be you. I want to understand your pain. So what you do is you're like, okay, this is anterior, this is medial, yeah? So I know that right now I'm looking at the back side of the bone and it's the right one. So in order to do siding, you have to find an anterior or posterior landmark. If you memorized an anterior one and you can't see it, you're looking at the back side. And then you have to find a lateral or medial landmark, right? So you can figure out how it goes. And it doesn't matter which one you use, right? That's up to you. You could use any one you want. If you actually wanted to use the auricular surface as the posterior landmark, you could. That's a hard one, but that's fine. And then you will always be able to figure out how it fits into the body. Does that make sense? That's siding. So siding a bone is not random memorization. One last thing and I'll let you guys go. The other good habit is that you need to realize that there is no guarantee that in your lab practical you will be able to touch the bone or pick it up. Now here's the deal. It may seem arbitrary, but if I put this bone down like this and label something on a lab practical, right, and you go through first and you flip it over, right, then the other person has a different question which may actually be harder and they may not actually see what's labeled. So the last part of your confident studying of bones is to work with a partner and say, okay, I'm gonna put this down and you can't touch it, and I want you to tell me the bone, I want you to tell me the side, and then I want you to tell me what this feature is without flipping the bone, right? So that is not an early thing, you won't get that first, but once you get into the later stages and you're ready for your lab practical, you should be able to do it from any position. And what I always have to do with these when it's not in the position I expect, I'm like, yeah, that's it right there, right? You have to like figure out how it would fit in your body. And you're gonna look like an idiot, but nobody's looking at you. It's like yoga. You look at somebody else doing yoga, you fall over. So